We were discussing alkanes, started with a fraction distillation and then cracking of a hydrocarbon. Then chemical reactions of alkanes. So chemical reactions of alkane. Number one, because these alkanes can be used as a fuel. So the first one is combustion. Combustion means burning these alkanes. When we burn, the reaction is exothermic. It releases energy. This energy or heat energy which is given off or energy given off can be used to generate electricity or for any other different purpose. So in combustion, if we have alkane plus oxygen, it will give, for a complete combustion, it will give carbon dioxide plus water. That will be the product which is formed by combustion of alkane. So when we burn these alkane reacted with oxygen, it gives carbon dioxide plus water. And the general formulas of alkane, as we know, like example, the general formula is CnH2n plus 2. So if you are burning an alkane C2, like it contains 2 carbon atoms, how many hydrogen atoms will be there in this alkane? If it contains 2 carbon atoms, how many hydrogen atoms will be there in this alkane?
Four.
It is alkane, ANE. It's H2N plus 2. So it will be 6.
Yeah, 6.
Because the number of hydrogen are twice plus 2. It reacted with oxygen. What's the formula for oxygen? Oxygen is O2. When they react with each other, this results in a formation of a product, carbon dioxide. Carbon dioxide is given by CO2 and gives water, H2O. This is the equation which is complete, but this equation is not balanced. The second thing is balance the equation. First thing is complete the reaction, like writing a correct product. Second thing is balancing. So how to balance the combustion equation? So to balance the combustion equation, what we will do, we will first balance carbon. Then hydrogen. And at the last, we will try to balance oxygen when we are balancing a combustion equation. So first we have to balance carbon. How many carbon atoms are there on the left hand side? How many carbon atoms on the left hand side?
2.
2. And how many carbon
2.
atoms? Yeah. And how many carbon atoms
1.
on the right hand side? 1. So first I told you for combustion equation, we balance carbon first. So on the left hand side, we have 2 carbon. So on the right hand side, we should also have 2 carbon. That's why I put 2. So when I put 2 before the carbon, now carbon is balanced. Is it clear? The first thing, we start balancing the combustion equation with carbon.
Yes.
Second, we will balance hydrogen, the second step. How many hydrogen on my left hand side?
6.
6. How many hydrogen on my right hand side?
2. So I put 3.
So we need 3. So 3 multiplied by 2, that makes 6. So oxygen is also, hydrogen is also balanced. So on the left hand side, we have 6 hydrogen. On the right hand side, we have 2 hydrogen. That's why I put 3 here. So that 3 multiplied by 2 will make 6 hydrogen. So hydrogen is also balanced. Now we had the third, we balance oxygen. To balance oxygen, how many oxygen on the right hand side total? This 2 is
4.
multiplied with this 2, 4, and this
3.
3 is also there, so make it
Yeah, 5.
7. 7, 4 plus 3.
Oh, so 7. Yes.
2 is 4, 2 multiplied by 2 is 4, and this 3 is there, that make it 7. Now I want to, how many oxygen I need here? I need 7. How I can have 7 oxygen here? 2 are
7
already
divided by
there.
2. 7 divided by 2.
So 7 by 2 or 7 by 2 means 3.5. Because if I put 3.5 or 3.5 means same thing in terms of fraction, it is means 7 by 2.
Yeah.
So what I can do, I can just write 7 by 2. Because 7 by 2 or 3.5 multiplied by 2, I will get 7.
I can write that like it shouldn't be a whole number like 3, 2.
This
like
is, this is the first thing. They accept this also. They accept this. If you stop at this point, that's correct. But if you want to write all of them as whole number, so because it is 7 by 2, so I need all of them in a whole number. What I can do, I can multiply all of them by 2. So this will become 2 C2H6. When this is multiplied, so 2 cancel with 2. So this will be 7O2. 2 2s are 4 CO2 plus 3 2s are 6 H2O. So you can write the first one, that's also correct, acceptable. You can write the second one if you want to write all of them in a whole number. So what we did, we multiply all of them by 2 so that it all will be whole number. Is it clear?
Yes, thank you.
Yes.
So if I say draw energy profile diagram for this reaction, it's an
Sir, should
exothermic.
we
Yes,
should we like multiply them by 2? Like, can't we write a fraction?
you can write fraction. That's why I just mentioned. You can write the first one. That's acceptable. You can write the second way. Both are correct. It does not make difference. So example, it's an exothermic reaction. So which substance will have more energy, reactant or product? Which substance will have greater amount of energy? If I want to make an energy profile diagram or energy diagram for this. So reactants have more energy and the product will have low energy.
Less energy.
Yeah. So if they say complete the energy profile diagram, so C2H6 plus oxygen is a reactant, 7 by 2 O2, and the product is 2 CO2 plus 3 H2O is a product. If they do not say mark activation energy, so you can just simply show an arrow downward that represent energy change or enthalpy change. Is it clear, this concept of?
Yes.
So these alkanes, hydrocarbons, can be used as a fuel. So how we use them as a fuel? We burn them in the presence of oxygen, which a complete combustion result in a formation of carbon dioxide and water. Yes, Salman, you have a question?
Sir, this is exothermic.
This is exothermic reaction. In exothermic,
The chart you made.
yeah, energy diagram. Yes.
This one.
Combustion is always exothermic.
Yeah, exothermic reaction means because the reactant release energy, so the product will have low energy. That's why it is an exothermic reaction.
So all the combustions are exothermic.
Any type of combustion reaction is exothermic. You're burning alkane, you're burning alkene, you're burning alcohol, you're burning any kind of fossil fuel, all of them releasing energy. That's why exothermic reaction. Another example. For combustion of alkane, if I say write a balance equation for combustion of C4, how many hydrogen will be there if it is an alkane?
10.
10. It gives carbon dioxide plus water, H2O. So C4NH10 burned in the presence of oxygen gives CO2 plus H2O. First combustion equation, we always start balancing with carbon, followed by hydrogen, and at the last oxygen. How many carbon on my left hand side?
4.
So I should put 4, so carbon is balanced. How many hydrogen atoms are there on the left hand side?
10.
10.
So we'll 5.
5 multiplied by 2 makes it 10. And how many
Yes.
oxygen?
We have 2.
4 multiply on the left hand side 2, on the right hand side 4 multiplied by 2 is 8, and plus 5. 8 plus 5, 13.
Yes.
So what I should write here? I'll write 13 by 2. Because 13 by 2, and because already 2 oxygen are there, so this 2 will cancel with 2, I'll get 13. Is it clear, this equation?
Yes.
Another example, if we have C5H12 plus O2 will give CO2 carbon dioxide plus H2O water. 5 carbon atoms are there. Yes, Salman.
What is this? This CHON with the arrow down?
It shows the order in which you balance the equation.
Oh, sorry.
You will start with carbon, then you will balance hydrogen, and at the last you will balance oxygen. That's the order in which you will balance the combustion equation. But
Sir,
normal,
is there any
yes,
why this order? Is there any reason why this order is specific?
yeah, there is a
Can
reason for organic compound, because organic compounds are hydrocarbon. Hydrocarbon means most of them are hydrocarbons. Compound contain carbon and hydrogen. That's why it is convenient to balance the carbon and hydrogen number. But this is not, it's not like a fix. You say you always try. This will make your balancing easy. Why it makes your balancing easy? Because in a compound, the hydrocarbons or organic chemistry, most of the compound contain carbon and hydrogen. So if you try to balance carbon and hydrogen number, then you are left with few atoms or elements at the last. That's why they follow this order. But if you want to follow another order, that's okay, because the final result is important. But if you follow this order, it make it easy to balance the equation.
All right, sir. Thank you.
So in the next, C5H12 plus O2 gives CO2 plus H2O. So you have 5 carbon atoms on the left hand side. So how many carbon atoms on the right hand side? So I should put 5. So carbon number is balanced. Hydrogen, I have 12 hydrogen. So I put 6 here, 6 multiplied by 2. So hydrogen is also balanced. And then oxygen, 5 multiplied by 2 is 10, and plus 6. So 10 plus 6 makes 16. So I need 16 oxygen. So already I have 2. So what I will do, I'll just simply multiply it by 8. So you can see here, when we started, we tried to follow or write a balance equation. We started with carbon, hydrogen. It just make it easy to balance the last number. This is valid for combustion, for hydrocarbons or combustion of organic compounds. This order. So this is the first reaction of alkanes. We burn them, we use them as a source of energy or the fuel. The second, look in this equation, if I try to balance, I'll start with carbon, followed by hydrogen, at the last oxygen. So on the left hand side, we have 4 carbon atoms. So on the right hand side, we should have 4 carbon atoms. So carbon is balanced. On the left hand side, I have 10 hydrogen. On the right hand side, I should have 10 hydrogen. So I put 5. So hydrogen is also balanced. But what about oxygen? 4 multiplied by 2 is 8. And this 5, 8 plus 5, that makes 13 oxygen. So I need 13 oxygen here. How I can make this 13 oxygen? So if I multiply by 13, so 13 multiplied by 2 is 26. And then if it is divided by 2, so 26 divided by 2. So what I will get? I will get 13 again. So simple way, if you need an odd number here, if you need an odd number of oxygen, then there should be a fraction here. If you need whole number of oxygen, like 16, 14, 12, then there will be a, sorry, if there is an odd number, there will be a fraction. But if there is an even number, like example, 2, 4, 6, 8, 10, 12, 14, 16, then at this point, you will have a whole number. If odd number of oxygen are there, then you will have a fraction. Is it clear?
Odd number of oxygen on the reactant side.
Product side, if you have odd number of, if you have, for balancing, you have odd number of oxygen, it means in the reactant side, you need a fraction to balance oxygen. If in a product side, you have an even number of oxygen, it means you need a whole number to balance oxygen. So copy this first part, chemical reaction of alkane. The first one is combustion. When we burn alkane, it gives carbon dioxide and water.
Sirzan?
Yes.
Sirzan, the slide before this was about cracking alkenes.
No, this is a, you mean last week we discussed cracking.
Yes, yes.
The last week, yeah,
The-
it was, the last week we discussed cracking of alkane. Now it's a chemical reaction of alkanes. The first reaction is combustion. You finish writing this?
Yes, sir.
The second reaction of alkane undergoes substitution reaction. This is the second reaction. The first reaction of alkane was combustion, means you're burning them. And the second reaction is called substitution reaction. with halogens. For this reaction, you have to first learn the reaction condition, means at what condition this reaction will occur. So reaction conditions, you need ultraviolet light, UV in short, and high temperature. For this reaction to occur, the conditions, you need an ultraviolet light and high temperature. So what is a substitution reaction? As you have a concept of substitution, like example, in case of football, if one player leaves the field, then the other player will take his position and he will enter the field. This is the same concept used here. That's why it is called a substitution reaction. So example, I have CH4. CH4 is, what's the name of this compound? CH4? It's an alkane.
Okay.
But what is the specific name? Because one carbon is there, that's why it is
Methane.
methane or methane, you can say. It reacted with halogen. Halogen means salt formers such as fluorine, chlorine, bromine, or iodine. So example, if there is chlorine, chlorine means Cl2. So what happened, how this reaction occur? As we know from the name, substitution means when one chlorine atom enter methane, one hydrogen will leave methane. That's why we call substitution. Means what happened? One hydrogen will leave and one chlorine will enter. So one carbon is there. As one hydrogen leaves, how many hydrogen I'm left with? Originally there are 4 hydrogen.
3.
So I'm left with 3 hydrogen atoms. So this will be CH3,
Hydrochloric acid.
and one chlorine also enters. So it will become CH3Cl.
Yes.
One hydrogen leaves and one chlorine enter. And then what will be the product? Because we are left with one chlorine and hydrogen. So hydrogen react with chlorine. What it will form? It will form HCl. Look, I'll repeat. The term substitution means if one atom enters the substance, the other will leave. So CH4, it means you have one carbon and 4 hydrogens. It reacted with chlorine. Chlorine means Cl2. So how we explain a term substitution? If one atom leaves, another atom will take its position. That's called substitution. So what happened? Out of 4 hydrogen, one of the hydrogen leaves methane. So if one of the hydrogen leaves methane, how many hydrogen we are left with? We are left with 3 hydrogen. So it is
3.
CH3. And because what happened? In place of that hydrogen, one chlorine took the position. So it will become Cl. So CH3Cl plus the hydrogen and the chlorine which is left here, this will form
It will be hydrochloric acid.
HCl. It's hydrochloric acid, or basically it's a gas given off. When if this gas dissolve in water, it will form hydrochloric acid. Is it clear? Why hydrogen leave? Because chlorine can form, in terms of structure, chlorine can form maximum 4 bonds. Carbon can form maximum 4 bonds. Carbon belongs to group 4. So it cannot form more than 4 bonds. 4 covalent bonds are there. This is in terms of structure. And chlorine belongs to group 7, so it can form a single bond. So what happened? As one chlorine take the position of hydrogen, the hydrogen must leave because chlorine cannot form 5 bonds, so one bond should break. Carbon cannot form 5 bonds, so one bond should break. So hydrogen is replaced by the chlorine. So what is the product? This product contains 3 hydrogen atoms and 1 chlorine plus HCl. Is it clear?
Yes, sir.
So reason for that, because the carbon maximum can form
Sir,
4
can you
bonds.
explain again the
Okay. So carbon belongs to group 4. As a carbon belongs to group 4, maximum it can form 4 bonds, not more than 4. So 1, 2, 3, and 4 bonds are there, already occupied with 4 hydrogen. But what happened? In the presence of ultraviolet light at high temperature, this out of 2 chlorine atoms are there in a molecule. So one of the chlorine atom, because it is more reactive, so it take the position of hydrogen. So when chlorine take the position of hydrogen, hydrogen will break the bond and leave this molecule. Why? Because carbon can form maximum 4 bonds. That's why you can
Displacement
see,
reaction.
yeah, it's the same idea, but why we call, there's a small difference between displacement and substitution. Substitution is refers to when one atom replace another atom, we call substitution. But displacement means when one molecule, the whole substance is replaced. Like if all of the hydrogen were replaced by chlorine, then I will say it's a displacement. But if only one of the atom is replaced by another atom, then I will call that as substitution reaction. Is it clear?
Yes, sir. Got it.
sir, what is the difference between the displacement and the
What is the
substitution?
difference between displacement and substitution? Look, example, if you have say magnesium oxide reacting with calcium, so calcium is more reactive, calcium will displace this. The whole atom means all of the atoms from a compound are removed. Like example, originally it was magnesium oxide, but now it is calcium oxide. This is displacement. But in substitution, what happened? CH4 was there and it was reacting with chlorine. So only one of the hydrogen atom is being removed. Remaining, like the other 3 are still there. That's why we call that as substitution reaction. It's still there is a hydrogen. Sorry.
Thank you.
Still there is a hydrogen atom. That's why, so it's a substitution reaction rather than you say displacement. If all of the hydrogen were replaced, like example,
Thank you.
if it was like this, then all of the hydrogen were replaced, it becomes CCl4 and plus hydrogen only. Then you will say this is a displacement reaction, that chlorine, all chlorine remove the hydrogen. Sorry.
Okay. Thank you.
But this reaction is a chain reaction. What is the meaning of a chain reaction? It means this reaction will continue until all of the hydrogen atoms are removed from the hydrocarbon. So first what happened? It was CH4. It reacted with chlorine. One chlorine enter, one hydrogen replaced. So what we are left with product? We are left with CH3Cl plus HCl. Then this product, still it has hydrogen. So this product will react with another chlorine molecule. So this is CH3Cl plus Cl2. So what will happen? Again, the same reaction will occur, that one hydrogen will come out and one chlorine will take position. So what will be the product? I will have one carbon. How many hydrogen atoms will be there in the product? There are 3 hydrogen atoms.
Yeah, so it will be
So if
2
one is replaced, so it will be 2.
CH2Cl2.
Yeah, and already one chlorine is there, one more chlorine is added, so it will become CH2Cl2 plus
HCl.
HCl.
HCl, hydrochloric acid.
But still this reaction will not stop, it will continue until all of the hydrogen are replaced. So what happened?
So 2 more reactions.
So 2 more reactions will be there. CH2Cl2. The product here reacted with another chlorine molecule. So what will be the product? Because one of the hydrogen is removed and one chlorine entered.
CHCl3. CHCl3.
CHCl3 plus HCl.
HCl.
And at the last, one more reaction. I don't have space, so I'm writing on the left hand side. So one more reaction will occur. So CHCl reacted with another chlorine molecule. One chlorine will enter and one hydrogen will replace. So it will become CCl4 plus HCl. So you can see the reaction continue until all of the hydrogen are replaced by chlorine atoms. Now this substance will not react, or this substance, because all of the hydrogen are replaced by chlorine, so there is no more hydrogen to be substituted. That's why the reaction will stop. Yes, Salman, you have a question?
Sir, like, can we name these also? Like
Yes, we can name.
CHCl.
Yes, we can name. There is a way to name. Because one chlorine is there and one carbon. So the first one chlorine and one carbon. So because of one chlorine, we say mono. Mono means one. And there is chlorine, so we say chloro. So monochloro means one chlorine.
Sir, which type of atom is this CCl4?
Which type of it? This is called tetrachloromethane. This is called trichloromethane. Maybe you heard of a compound known as chloroform.
Sir, why methane? There is no hydrogen.
But the name of, I told you the prefix used only for carbon, not for hydrogen. So mono is for one, chlorine is there, and because there is one carbon, so we say meth, and they have a single bond, so we say ane. So it is monochloromethane. What is the name of this compound? It contains 2 chlorine, so we say it is 2 chlorine is there, so 2 dichloro, and because of one carbon we say meth, and because they will have a single bond, so we say ane. So it's dichloromethane. This compound contains 3 chlorine, so what will be the name? Tri, because of 3 tri. Chlorine are there, so chloro, and because one carbon meth and single bond ane, so it's trichloromethane. And this trichloromethane is also known as a chloroform. Have you heard of chloroform? What is the purpose of the chloroform?
No.
No.
Chloroform, if you use, it's not for air conditioners. Chloroform not refrigerator. Yeah, I'm saying these gases like chloromethane and these gases are used as a coolant in a air condition, but chloroform,
So then how is HCl called hydrochloric acid? Like,
This is called hydrogen chloride gas. Hydrochloric acid means that if it dissolve in water, like example, if HCl is there, you add HCl in water, hydrogen chloride gas in water, so it will form H plus and Cl minus. What is the definition of acid? Acid are proton donor. Anything which donate proton or gives out proton, we call that as acid.
Yes.
No, sir. I'm saying, how is it named? Like, shouldn't it be monochloro or something like that?
No, that's monochloro. These are the for hydrocarbons only.
Oh,
This is the IUPAC name for hydrocarbon. Hydrogen chloride
So,
is
sir,
inorganic chemistry. Inorganic chemistry, we name the first element as it is. So we say hydrogen. And if the second element is alone, so the name should end at ID. And so that's why we called that hydrogen chloride.
sir, the CCl4, is it a hydrocarbon?
CCl4, but the main, it is originated from the, it's not a hydrocarbon, but it is
Hydrocarbon.
originated from the hydrocarbon. That's why we call that as tetrachloromethane.
Or
So this one is known as tetra. Tetra means 4. Chloro because of chlorine, and meth because there's one carbon in it. So first you started with methane. When one chlorine take position of hydrogen, it become monochloromethane. When two chlorine atoms replaces the hydrogen, then it becomes dichloromethane. When 3 chlorine atoms displaces the hydrogen, we call trichloromethane. And when 4 chlorine replaces the hydrogen, we call that as tetrachloromethane. This reaction is a chain reaction. It will continue until all of the hydrogen present in the hydrocarbon are replaced by chlorine. But this is a simplest one. Like example, we started with methane, but this can happen for any alkane. Like if you have an alkane, say C4 and H10, it's butane. If butane reacted with chlorine, so what will be the first product? Chlorine will take position of hydrogen, hydrogen will take position of chlorine. So it will become C4 H9 Cl plus HCl. HCl will always be there, hydrogen chloride gas. Then C4 H9 Cl reacted with another chlorine. So it will form C4 H8 Cl2 plus HCl. And this will continue so this will occur